This system turns trash into cooking gas. So why are you still paying for energy? Right now, this flame is powered by waste. Not a company, not a bill, not a pipeline. Just chemistry, working silently every single day. And the part most people miss, it works every single day, without fail, without a subscription. You've been taught that energy comes from infrastructure, that somewhere there's a plant, a pipe, a meter, a company, and that without all of them functioning perfectly on your behalf, you don't get to cook your food or heat your home. You were taught that you need permission to live, and that permission comes with a bill. Every month, without exception, going up every year. But that dependence is designed. It wasn't inevitable. It wasn't the only option. It was a design choice made by people who benefit from your dependency. Because energy can come from something you throw away every single day, something you bag up and leave at the curb, something you've never once thought of as fuel. Your food scraps, your organic waste, your kitchen leftovers. They contain stored chemical energy, real energy, measurable energy. And right now, you're paying to have it taken away, then paying again to replace it. That's not a utility bill. That's a tax on not knowing. So here's what the system actually looks like. Not a power plant, not an industrial facility, not something that requires an engineering degree or a significant investment. A sealed container, a few pipes, a valve, and bacteria. That's it. This is a biodigester, and at its core, it does one thing. It creates an oxygen-free environment where naturally occurring microorganisms break down organic material and release the energy stored inside it. The technical term is anaerobic digestion, but you don't need the technical term. You need the result. You feed it your kitchen scraps, your vegetable peels, your coffee grounds, your leftover food, your grass clippings, mixed with water, sealed inside. The bacteria go to work. No input from you, no electricity needed, no external materials required. Just time and biology, doing what biology has been doing for 3.5 billion years. As the organic material breaks down, it releases a mixture of gases, primarily methane, the same fuel that powers commercial gas stoves, the same fuel in the pipeline running to your house right now. Except this methane didn't come from a gas field in another state. It came from yesterday's vegetable peels. As the gas accumulates in the sealed chamber above the digesting slurry, pressure builds. That pressure pushes the gas through a pipe to wherever you need it. A kitchen burner, a water heater, a small generator. The flame is clean. The heat is real. The energy output is consistent and measurable. 1 to 2 kilograms of food waste per day produces between 300 and 700 liters of biogas. That's enough for basic daily cooking, enough for hot water, enough to run a small generator for several hours. Every day, from what you were throwing away. No magic, no theory, just chemistry working for you instead of against you. But energy is only the beginning, because when organic material goes through anaerobic digestion, the bacteria don't consume everything. What's left is a liquid residue called digestate. And digestate is not waste. It is the most nutrient-dense, biologically active natural fertilizer that exists. Dense in nitrogen, phosphorus, potassium, micronutrients, and living beneficial microorganisms. It comes out of the system ready to apply directly to soil. No processing, no treatment, no purchase. Your kitchen waste goes into the system as fuel, and comes out the other end as premium soil amendment. You stop buying fertilizer, your soil gets richer, your food grows better. From the same waste stream that was costing you money to discard. One input, two outputs, zero waste. Now let's look at the full picture. Organic waste goes in, biogas comes out. You cook your food with it. The cooking produces more scraps. The scraps go back into the system. Digestate comes out the other end. It feeds your soil grows your food produces scraps. The scraps feed the system. Waste becomes gas becomes energy, residue becomes fertility becomes food becomes waste. The loop closes. Nothing leaves, nothing is discarded. Everything feeds the next step. This is not idealism. This is thermodynamics. Energy doesn't disappear, it transforms. And when you design your system to capture those transformations, you stop losing value and start keeping it. One system, multiple outputs, compounding returns. So how do you actually build one? At the small-scale residential level, the materials are basic. A plastic drum or HDPE tank, standard plumbing fittings, a flexible hose, a pressure valve, a gas outlet connection. The construction principle is simple. Create an airtight vessel, add an inlet for feeding organic material mixed with water, add a sealed interior chamber where digestion occurs, add a gas collection space at the top, add a gas outlet pipe, and add an effluent outlet for the digestate. The bacterial culture can come from active compost, animal manure, or pre-inoculated starter material. Once established, it self-maintains indefinitely as long as you feed it regularly. Feed daily, keep it warm, maintain the right water-to-waste ratio, and keep contaminants out. No plastics, no synthetic chemicals, no oils in excess, no meat in high quantities for small systems. The bacteria are the workers. Your job is to keep the environment stable. Do that, and the system runs itself. Temperature is the single most important variable. Mesophilic bacteria, the type used in most home biodigesters, work best between 20 and 40 degrees Celsius. In warmer climates, systems run year-round with no intervention. In cooler climates, simple insulation or siting in a sun-facing position extends the operational season significantly. Below 15 degrees Celsius, production slows substantially. Below 10, it essentially stops. This is not a problem, it's a design parameter. Scale works the same way. A 200-liter drum handles a small family's kitchen waste and produces enough gas for basic daily cooking. A 1,000-liter system handles a larger household or small farm operation and produces enough for cooking, water heating, and supplemental power generation. Community-scale systems used across rural Asia, sub-Saharan Africa, and South America handle the organic waste of entire villages and produce gas that powers communal kitchens, street lighting, and small-scale industrial processes. The technology scales from a backyard drum to a regional energy system. The physics is identical at every scale. So why isn't everyone doing this? Because dependence is easier than understanding. Because a utility bill requires no thinking, no building, no maintenance, no learning. You pay, you get energy. The system is invisible to you. And invisible systems are comfortable. But invisible systems are also systems you can't control. When the price goes up, you pay more. When the supply is disrupted, you go without. When the company changes its terms, you accept them, because you need them more than they need you. You were taught to consume, not to build. Consuming is passive. Building requires understanding.
and most people were never taught to understand the systems they depended on. They were taught to use them. That asymmetry between those who understand systems and those who only use them is where economic leverage lives. Now, if you're thinking this only works in rural settings, in large properties with land and space, that's the limitation most people assume. It's not accurate. Compact biodigester designs exist specifically for urban and peri-urban environments. Units designed for balconies, small yards, rooftops, and community spaces. These adapted systems are smaller, more contained, and designed for apartment-scale waste streams.
A household of 4 people produces more than enough organic waste to run a compact urban biodigester. The gas output covers a meaningful portion of daily cooking needs. The footprint is comparable to a medium-sized recycling bin. Space is a design constraint, not a barrier. And when built correctly, these systems are safe. Biogas pressure in residential systems is low, far lower than the pressure in a conventional gas line. The gas is lighter than air, meaning leaks dissipate upward rather than accumulating at ground level. The flammability risk is real and must be respected. Connections must be properly sealed. The system must be positioned with ventilation. A simple pressure relief valve prevents accumulation beyond safe levels. These are manageable engineering parameters, not obstacles. Every energy system carries risk. Natural gas pipelines carry significantly higher pressure and wider distribution of the same fuel. The difference is that you can see, touch, and maintain your own system. Understanding removes fear, and understanding comes from building. Now, imagine going further. The biodigester is one system, but it doesn't stand alone. Stack it with a rainwater collection system, gutters, storage, gravity distribution, and you eliminate your water bill alongside your gas bill. Stack it with a solar array, even a modest one, and you cover your electrical load with the biogas generator handling the gap on cloudy days. Stack it with a food production system fed by the digestate, raised beds, vertical growing, a small food forest, and you reduce your grocery bill alongside your utility bills. Each system makes the others more productive. Water fed by rain, soil fed by digestate, energy from waste, soil fed by food, waste back into the digester. No single point of external dependency, no single bill that can spike and destabilize your whole operation. This is not a survival strategy. This is a productivity architecture. And every layer you add compounds the value of the layers below it. In nature, nothing is wasted. The leaf that falls from the tree feeds the fungi. The fungi feed the soil. The soil feeds the tree. The tree drops leaves. Every output is the input for something else. Every death is a resource for something living. The forest doesn't pay an energy bill. The ocean doesn't buy fertilizer. The prairie doesn't import water. These are closed-loop systems that have been running, compounding, and self-optimizing for billions of years. What we call waste is a design flaw. In a well-designed system, there is no waste. There are only misplaced resources. And the difference between a misplaced resource and a productive input is a single design decision. Waste is not the problem. Design is. You were handed a system designed around dependence, designed to need a pipeline, a meter, a bill, a company, a supply chain for every basic function of your life. And it works, until it doesn't, until the price spikes, until the supply is disrupted, until the infrastructure fails, until the terms change. The system wasn't built for your resilience, it was built for your compliance. And the first step out of it is understanding that the resources you need to build something different are already in your hands, or more precisely, already in your trash. So the question is simple. What would you replace first? The energy bill? The fertilizer cost? The grocery run? Because once you understand the system, once you see the loop clearly, every bill you pay starts to look like a design problem with a solution. And the solution starts with the scraps on your cutting board. Because once you see the system, you can't unsee it. Replace the dependency. Build your own.